Today we're going to take a look at some structures that are pushing the limits of physics in ways that seem impossible, proving that today's engineers have truly mastered gravity. So for today's video, we're going to take a look at 15 gravity-defying buildings. Starting with number 15, the Capitol Gate Tower in Abu Dhabi. The Capitol Gate Tower in Abu Dhabi is one of the most striking architectural feats of the 21st century. It's known for this dramatic lean that appears to defy gravity. Completed in 2011, this 35-story skyscraper stands 165 meters or 541 feet tall, and it leans 18 degrees to the west, over 4 times the tilt of Italy's Leaning Tower of Pisa. To achieve this controlled tilt, the engineers employed some of the most advanced structural techniques ever used in a skyscraper. The core was constructed slightly off-center and reinforced with a dense mesh of steel. As each floor was added, the concrete core was deliberately offset from the previous one by between about 300 and 1400 millimeters each floor. This created a gradual, calculated curve that produced this final 18-degree inclination. To stabilize the whole thing, the foundation had to include 490 reinforced concrete piles that were driven about 30 meters down into the ground to counterbalance the lateral load caused by the lean. Let's talk about the exterior. It's clad in some complex glass facade made up of about 720 unique diamond-shaped panels. Each pane was precisely fitted to accommodate the curved geometry and to minimize any solar gain in the climate there. It incorporates a diagrid frame, which is a diagonal steel grid that distributes the weight efficiently and allows the building to maintain that shape without internal columns or obstructing interior space. Inside, the tower has office spaces on the lower floors and the 5-star Andaz Capitol Gate Hotel, operated by Hyatt, on the upper levels. The hotel lobby is located on the 18th floor. You can reach that through a glass-walled elevator that gives visitors a clear view of the distinctive tilt. And the Guinness World Records officially recognized the Capitol Gate Tower as the world's furthest man-made leaning building in 2010. Unlike Pisa's accidental tilt, this one was achieved through exacting control over structural loads. Even after more than a decade, it still is one of the most visually cool-looking towers, a deliberate, stable, and elegant defiance of gravity. Number 14, the Hanging Temple of Hengshan in China. Clinging to a cliff face in the Shanxi province, the Hanging Temple of Hengshan is a masterpiece of ancient Chinese engineering. It's survived for over 1,500 years. Built into a rock wall 75 meters above the ground, that's 250 feet, it appears to just float in midair. It's an illusion created by the delicate wooden structure and location. The temple, also known as Wangkongsi, was originally constructed around the late 5th century CE during the Northern Wei dynasty. It consists of 40 wooden halls and pavilions connected by narrow walkways, supported by beams embedded directly into the cliff. Despite its fragile appearance, the temple's design is pretty stable. The cliff above provides natural protection from rain and sunlight, while the surrounding gorge shields it from strong wind. The main halls contain sculptures of the Buddha, Laozi, and Confucius, among dozens of other deities and saints, and archaeological studies have showed that the temple underwent several periods of renovation during the Ming and Qing dynasties, each reinforcing or expanding the structure without compromising the original design. Over the centuries, local craftsmen have replaced the decaying wood while also maintaining the same traditional joinery techniques. No nails were used in the original construction, and modern restorations have remained faithful to that approach. Today, access is through a narrow wooden staircase that hugs the cliff. It offers visitors an amazing view of the gorge below. But due to safety and preservation concerns, entry is limited to certain seasons, but visitors can still explore many of the original rooms and shrines. For more than 15 centuries, it's remained suspended between the earth and the sky. This is a symbol of human ingenuity, literally hanging against all the odds. Number 13, the Dynamic Tower of Dubai. The Dynamic Tower, this is also known as the Da Vinci Tower. It's one of the most ambitious concepts ever proposed, a building designed to move. Planned for construction in Dubai, this skyscraper is going to consist of 80 independently rotating floors, each able to turn 360 degrees around a central core. Although it is still unbuilt, the design has been fully developed and patented by Italian-Israeli architect David Fisher, making it a legitimate and technically viable project rather than just speculative fantasy. The concept was first announced in 2008, with renewed plans revealed in the 2010s. The tower's proposed height, 420 meters. That's 1,375 feet. It would make it one of the tallest residential buildings in the world. Each floor would rotate independently at varying speeds, controlled by the residents, creating a constantly shifting skyline and giving the building a new shape every minute. This dynamic movement would be powered entirely by renewable energy, horizontal wind turbines placed between the floors, and solar panels on the roof and outer surfaces. The rotating floors, each a prefabricated module with plumbing, wiring, and all the interior finishes already installed, would then be attached to a core through a central bearing and powered mechanism. According to Fisher's plan, 90% of the tower could be assembled off-site in a factory, which would drastically reduce the labor time and cost. However, engineering challenges have delayed the project. The rotation mechanism, involving advanced bearings and power controls for each floor, has exact tolerances and it needs to ensure stability. While smaller prototypes and tests have proven feasible, scaling the system to an 80-story skyscraper is expensive and complex. Despite the hurdles, though, the dynamic tower has been recognized within architectural circles as an innovation. It's influenced several smaller kinetic architectural projects around the world where the facades or building elements move in response to light, wind, or temperature. If completed, though, it would become the world's first truly moving skyscraper, a structure that doesn't just stand against gravity, but actively redefines what a building can be. If ever realized, the dynamic tower would mark a literal turning point in architecture. Number 12. The Lotus Temple in New Delhi. The Lotus Temple in New Delhi in India, completed in 1986, is a cool example of how architecture can evoke the illusion of weightlessness. Designed by Iranian architect Farabor Sabah, the temple serves as the Baha'i house of worship. It's become one of India's most visited landmarks. The structure is shaped like a giant lotus flower, which is an important symbol of purity and unity in Indian culture. It consists of 27 freestanding marble-clad petals arranged in groups of 3 to form 9 sides. These curved petals rise from a circular base and appear to float above 9 surrounding pools of water. The geometry of the building was calculated to create the impression that the heavy marble surfaces are unfolding naturally towards the sky. Those petals are made from reinforced concrete covered with white marble from the Penteli mountain in Greece, the same source used for the Parthenon in Athens. Each petal is a self-supporting shell structure designed to distribute the weight evenly through hidden ribs. The entire building stands about 34 meters or 112 feet tall and can accommodate up to 2,500 people inside the central hall. Despite the size, though, the temple has no internal columns. Instead, the petal-like shells carry the full load, creating a huge, unobstructed interior space filled with natural light. Inside, there are no altars, icons, or pulpits, only a hall for prayer and meditation. That interior lighting is achieved through skylights and diffused sunlight filtering between the marble petals, giving the space a calm, almost ethereal glow. The architect and his engineering team work closely with the consulting firm Flint & Neil from the UK to perfect the geometry of these petal structures. The surrounding pools are not just decorative either, they're also helping cool the building naturally by evaporative airflow, which is a sustainable design element that's decades ahead of its time. Since its completion, the Lotus Temple has received numerous awards and it's been featured in publications around the world. It's a pretty neat symbol of harmony between the faiths, cultures, and even between the natural and built environments. Through careful engineering and artistry, the Lotus Temple achieves what few buildings manage: the illusion of floating marble, a monument to both human ingenuity and spiritual grace. Number 11. The Habitat 67 in Montreal, Canada. Habitat 67, this is located on the St. Lawrence River in Montreal, Canada, was one of the most unconventional residential buildings ever constructed. It was completed for the World's Fair Expo in 1967. It challenges the aesthetic and structural norms of the time. The design was composed of 354 identical concrete cubes stacked together in irregular formations. It appears to defy gravity as the blocks kind of jut outward and upward at these unpredictable angles, forming terraces, bridges, and voids that seem to hang in midair. The architect Moshe Safdie's vision for Habitat 67 came from his graduate thesis at McGill University, in which he proposed a new kind of urban housing that combined the density of high-rise living with the privacy and green space of suburban homes. The result was a project that was experimental and practical, a prototype for modular housing that could, in theory, be mass-produced. Each cube measures about 38 by 17 feet, and it was prefabricated at a nearby factory before being assembled on site with cranes. The entire complex has about 158 apartments of various sizes, created by interconnecting the individual cubes. Some units have rooftop gardens, others have cantilevered balconies, and many are connected by outdoor walkways that give the impression of suspended bridges. But from an engineering standpoint, it was a remarkable achievement for its time. Each cube supports its own weight, as well as portions of adjacent cubes through a system of reinforced steel connections. This modular construction system, where each component is both simultaneously independent and interdependent, gave the building its signature floating appearance while maintaining its structural stability. But despite the futuristic design, Habitat 67 didn't become the mass housing solution Safdie envisioned, due to the high cost of construction and complex assembly process. Still, though, it became a cool landmark that influenced generations of architects interested in modularity and sustainable urban living. Over 50 years after its completion, it still remains in use, with most units privately owned. The building has been recognized as a National Heritage Site in Canada and continues to attract architects, engineers, and tourists. It was one of the most iconic architectural experiments of the 20th century, a permanent reminder that stability can coexist with structural freedom. Number 10. The Turning Torso in Malmö, Sweden. The Turning Torso in Sweden is the world's first twisting skyscraper, which was a feat of modern engineering that combined art, geometry, and structural innovation that was completed in 2005. This 190-meter-tall or 623-foot residential tower redefined what was possible in vertical design. The design was thought of by Spanish architect Santiago Calatrava, who based its form on one of his own sculptures depicting a twisting human torso, hence the name. The building consists of 9 5-story segments that rotate progressively as the tower goes up. The entire structure twists about 90 degrees from the base to the top, creating this visual effect of a massive spiral stretching to the sky. To manage all the complex forces generated by this twist, the engineers had to use a combination of high-strength concrete and steel trusses. The outer framework is composed of a visible exoskeleton of white steel beams that connect to the internal core at each level. These braces stabilize the twisting motion and they distribute the weight evenly, preventing the tower from leaning or swaying. The result is a building that looks as if it's in motion, but it remains firmly balanced. Each of the 54 floors has a unique shape and orientation, making construction challenging because more than 2,800 different window panels were fabricated, no two exactly alike, to match the continuously changing geometry. Precision alignment was crucial, of course. Errors of even a few centimeters would have compromised the entire thing. When it was completed, it became the tallest residential building in Scandinavia, and it was an instant symbol of Malmö's transformation from an industrial port into a modern technology hub. Calatrava's creation pushed the boundaries of what could be achieved with reinforced concrete and digital modeling. The seemingly impossible twist isn't a visual illusion, but a precisely calculated structural feat. Today, the Turning Torso remains one of Europe's most admired skyscrapers. It's an example of how architecture can challenge gravity while maintaining perfect balance. Number 9. The Forth Bridge in Scotland. The Forth Bridge, this was completed in 1890, was one of the greatest engineering achievements of the 19th century and a true gravity-defying structure in the world of civil engineering. Spanning the Firth of Forth near Edinburgh, Scotland, this massive railway bridge remains a masterpiece of balance. The cantilevered form appears to hang effortlessly in midair. It was designed by Sir John Fowler and Sir Benjamin Baker. The Forth Bridge was built to carry trains across a 1.5-mile stretch of water where the winds are pretty strong and the currents are unpredictable. Earlier attempts at crossing it had failed due to insufficient structural understanding, but the Forth Bridge changed that permanently. It was the first major structure in the world to use steel instead of wrought iron, which was a revolutionary shift that allowed for greater spans and unprecedented load-bearing. The cantilevers project outwards towards one another and connected by suspended spans that appear to float between them. Now, this design works by balancing the opposing forces. The outer arms of each cantilever counteract the weight of the central suspended section, and the result is a bridge that maintains equilibrium purely through geometry and the physics of tension and compression. In total, the bridge has over 53,000 tons of steel that's held together by about 6.5 million rivets. During construction, around 4,600 workers were employed, and the project took 7 years to complete. Each of the main spans measures about 521 meters or 1,710 feet, and the structure is 110 meters or 361 feet above the high water level. The bridge was so strong and overbuilt for its time that it remains in daily use more than a century later, carrying trains between Edinburgh and northern Scotland. It was officially opened on March 4, 1890 by the Prince of Wales, later King Edward VII, and it's since become one of Scotland's most recognizable landmarks. In 2015, it was inscribed as a UNESCO World Heritage Site, and from an engineering standpoint, it's a perfect demonstration of how balance, not mass, keeps large structures standing. Even today, it is regularly inspected and maintained, making it a living monument to the moment when human ingenuity first conquered the challenges of large-scale steel construction. Number 8. The Fallingwater House in Pennsylvania. Few structures in the world integrate gravity, balance, and nature as seamlessly as Fallingwater, the famous house designed by architect Frank Lloyd Wright in 1935. It's located in the forests of southwestern Pennsylvania. The home is built directly over a waterfall on Bear Run Stream. Its daring cantilevered terraces stretch out over the rushing water and appear to float in space while supported by a hidden system of reinforced concrete beams. Commissioned by Pittsburgh department store owner Edgar J. Kaufman, Fallingwater was intended as a mountain retreat that would blend in harmoniously with the surroundings. Wright took this request literally. Rather than positioning the house beside the waterfall, as Kaufman had expected, he placed it directly on top of it. The result was one of the most iconic designs in modern architecture, a building that seems to grow out from the rocks, yet hangs weightlessly above them. The structure is composed primarily of locally quarried sandstone and reinforced concrete. This balance between anchored mass and outward thrust allows the terraces to project far beyond their supports without any visible columns. The construction, which was completed in 1939, did push the limits of engineering for its time. Wright's vision led to disputes with structural engineers who worried that these cantilevers would not bear their intended loads. The house has since required reinforcement to correct slight deflections in the concrete slabs, but it has endured for over 80 years, which shows the strength of the original design. Inside, Wright designed every detail, from built-in furniture to the seamless transitions between the rooms, to emphasize the flow and connection with nature. The sound of the waterfall is constantly audible, and the house's windows open directly onto terraces that extend into the surrounding forest. The palette of materials, stone, glass, and wood reflect the colors of the natural environment, which reinforces the sense that the building's part of the landscape rather than just imposed upon it. Fallingwater has been celebrated as one of the greatest architectural works of the 20th century. It's been designated a National Historic Landmark, and in 2019 was inscribed as a UNESCO World Heritage Site. What makes it gravity-defying, though, is not only the physical structure of it, but the philosophy. Wright challenged conventional architecture by merging the built and natural worlds, making gravity itself a design element to be balanced rather than resisted. The house remains a work of art and proof that stability and grace can coexist on the very edge of possibility. Moving on to number 7, the Gateway Arch in St. Louis. St. Louis, Missouri, the Gateway Arch. It's one of the most remarkable examples of modern engineering. It was completed in 1965, and it stands about 192 meters or 630 feet tall, making it the tallest arch in the world and the tallest monument in the United States. Designed by Finnish-American architect Eero Saarinen, the Gateway Arch is conceived as a symbol of America's westward expansion, but its perfect form and flawless stability make it one of the greatest gravity-defying architectural feats ever built. The elegant, sweeping shape is a catenary curve. This is a natural form taken by a free-hanging chain when held at both ends. This design was chosen for its inherent stability. A catenary arch distributes weight evenly along its curve, allowing it to stand entirely through compression without any internal supports. In theory, it is one of the most stable shapes in engineering, but building one at monumental scale required exacting precision. It consists of two triangular legs made of double-walled stainless steel, each narrowing from about 16 meters or 54 feet at the base to just 5 meters or 17 feet at the top. The legs were constructed separately from massive reinforced foundations that were sunk about 60 feet underground, and each leg was built from hollow, prefabricated steel sections. Inside the arch, a network of steel diaphragms and stiffeners maintained rigidity while allowing for controlled thermal expansion, which was crucial for a metal structure exposed to the elements. During construction, engineers had faced one of the most delicate challenges in modern architecture: the final joining of the two legs. As they approached the apex, the gap between the tips measured less than a meter. To make the connection, precision hydraulic jacks adjusted the alignment while temperature variations were carefully monitored. Even a few degrees of difference could shift the steel enough to prevent the sections from fitting. On October 28, 1965, after 32 months of construction, the final keystone section was hoisted into place with millimeter accuracy, completing the perfect arc. Despite the appearance of weightlessness, the structure weighs more than 17,000 tons, and it can sway up to 46 centimeters or 18 inches in strong wind. The movement is imperceptible to any visitors. The interior includes a tram system that carries passengers to an observation deck at the top, which offers amazing views of St. Louis and the Mississippi River. For more than half a century after its completion, it continues to stand as one of the most graceful and precise monuments ever built, a seamless curve of stainless steel that embodies the triumph of human design over gravity. Number 6. The Marina Bay Sands SkyPark in Singapore. Completed in 2010, Singapore's Marina Bay Sands complex is one of the most recognizable buildings in the world. It's famous for its massive rooftop structure that appears to float above 3 skyscrapers. The project includes a hotel, casino, convention center, museum, shopping mall, and the SkyPark, a 340-meter, 1,100-foot cantilevered platform that gives the entire complex that gravity-defying silhouette. The SkyPark connects the tops of 3 55-story hotel towers at a height of over 200 meters or 650 feet. It stretches beyond the third tower a little bit with a cantilever of about 220 feet, making it the longest cantilevered platform in the world. That section alone weighs over 7,000 tons and had to be constructed with millimeter-level precision. During construction, the towers had to be designed to sway independently during wind loads, which required flexibility between the SkyPark and the towers to allow for differential movement without causing any stress fractures. The challenge of supporting a deck of this scale so high in the air was huge. The cantilevered section is counterbalanced by the weight of the central and opposite ends of the platform, which extend across the 2 other towers. Massive steel girders run beneath the SkyPark that's hidden from view, and they distribute the loads across multiple points of support. The SkyPark contains this infinity-edge swimming pool that runs nearly the entire length of the central section. The pool's edge looks like it drops directly into the sky and creates one of the most photographed architectural views in the world. In addition to the pool, it features restaurants, gardens, an observation deck, and of course event spaces, all built atop a surface suspended hundreds of meters in the air. This building stands as a statement of human capability where advanced mathematics, structural innovation, and artistic imagination come together to literally raise the limits of design. The SkyPark is one of the most audacious achievements of the 21st century, an elevated example of how far architecture can push against the pull of gravity. Number 5. The Bosco Verticale in Milan. The Bosco Verticale, or Vertical Forest, is a pair of residential towers in Milan, Italy, that reimagines urban architecture by merging structure and ecology. Completed in 2014 and designed by Stefano Boeri Architetti, the project consists of 2 towers, one 111 meters or 364 feet tall, and the other 76 meters or 249 feet tall, each covered in thousands of trees and plants that climb the facades and terraces. Together, it has over 20,000 plants, 800 trees, and 15,000 perennials, creating an entire ecosystem suspended above the city. The towers have to support not only their concrete and steel frames, but also the living weight of soil, water, and vegetation, elements that do shift and grow over time. Each tree and plant was carefully selected based on weight, root depth, and wind resistance, and engineers had to develop specialized planters and anchoring systems capable of holding trees up to 9 meters tall, ensuring they could withstand wind speeds of up to 80 miles an hour. The balconies, which extend irregularly from the towers, appear to float, and each is designed with cantilevered concrete slabs with hidden reinforcement, allowing the vegetation to spill outward without any visible supports. But beyond aesthetics, it functions as a vertical ecosystem. The trees can absorb carbon dioxide, they produce oxygen, and filter fine dust particles from the air, while the plants help regulate the temperature and humidity inside the apartments. The irrigation system recycles gray water from the residents there, and maintenance crews, including trained arborists, rappel from the roof to prune and monitor the trees. Sensors and load monitoring systems were all integrated into the slabs to track the variations in real time, and the resulting design is a rare fusion of biology and architecture, living matter coexisting with reinforced concrete in equilibrium. The Bosco Verticale has won the International High-Rise Award in 2014, and it was recognized as the world's best tall building by the Council on Tall Buildings and Urban Habitat in 2015. These towers appear light and alive, a self-sustaining forest that was lifted up into the air. This is a symbol of how cities can rise vertically without losing their connection to nature. Number 4. The Ponte Vecchio, Florence, Italy. The Ponte Vecchio, or Old Bridge in Florence, is one of the world's most iconic bridges, and one of the oldest still standing. Spanning the Arno River, it was completed in 1345, and what makes it remarkable is not just its survival, but its form. It's a multi-span stone arch bridge that supports entire rows of shops and houses on both sides that appear to hang impossibly over the water. The bridge we see today replaced an earlier wooden version that was destroyed by floods. Historical records are unclear about that and the actual designer, but the Ponte Vecchio is built using closed spandrel segmented arches made of stone. It measures about 95 meters or 312 feet long and 32 meters or 105 feet wide, with 3 main arches resting on stone piers anchored deep into the riverbed. Those arches distribute the weight evenly across the structure, which allows it to bear the added load of buildings constructed directly on top of it. During the Middle Ages, the bridge became a commercial hub of sorts for butchers and tanners who used the river below to dispose of waste. In the 16th century, the Duke transformed it into a more prestigious setting by evicting the trades and replacing them with jewelers and goldsmiths, a tradition that continues today. Above the shops runs the Vasari Corridor, an enclosed elevated passageway that was commissioned in 1565 by the Medici family to connect Palazzo Vecchio with the Palazzo Pitti. This private walkway spans the bridge's length, and it adds yet another layer of complexity to this structure. But the bridge's survival is remarkable, considering every other crossing in Florence was destroyed during World War II. In 1944, German forces retreating from the city demolished the surrounding buildings, but they left the bridge intact, reportedly on direct orders from Adolf Hitler, who admired it. Today, the bridge is one of the most photographed landmarks in Italy. The small shops and houses perched above the flowing river seem to float on air, a delicate balance between architecture and gravity, perfected centuries before modern engineering. For nearly 700 years, it stood as both a bridge and an example of humanity's ability to build beauty into the laws of physics themselves. Number 3. The CN Tower in Toronto. When it was completed in 1976, the CN Tower became the tallest freestanding structure on Earth, a title it held for more than 30 years. It stands 553 meters or 1,815 feet above Toronto's skyline and was built by Canadian National Railways, both as a telecommunications hub and as a demonstration of Canada's engineering. Nearly half a century later, the CN Tower remains one of the most astonishing achievements in modern history. A structure so tall and slender and stable, it continues to appear as though it's balancing effortlessly against gravity. The need for the tower came in 1960, when Toronto's skyline that was growing at the time began to interfere with radio and television signals. Engineers decided the solution was to build a single, very tall broadcasting structure that would rise way above any future construction. The project began in 1973 and took 40 months to complete. More than 1,500 workers labored year-round, often in extreme weather, to build what was, at the time, the most complex concrete structure ever attempted. The tower's design is based on a tapered hexagonal shaft made of high-strength slip-formed concrete. Now, this technique involved continuously pouring concrete into a climbing mold that rose slowly as the material set. This was a method that allowed the main shaft to be built without any seams or interruptions. The base itself measures 66 meters or 217 feet wide, which gradually narrowed to just 25 feet near the top. That gradual tapering helped the structure remain stable under any high wind by reducing the surface area and any drag. The base anchors the structure firmly to the ground, allowing it to withstand wind speeds of up to about 260 miles an hour and earthquakes measuring up to magnitude 8.5. And despite the height, the tower's sway at the top is only about a meter, which is 3 feet during high wind. It's barely perceptible to any visitors. The construction of the upper levels, including the sky pod and the antenna mast, posed unprecedented challenges at the time. The circular observation deck and revolving restaurants there were assembled using massive steel frameworks, lifted by cranes mounted directly onto the tower. The final section of the antenna mast, weighing over 7 tons, was installed by helicopter, which was a maneuver that demanded perfect weather and absolute precision. But the CN Tower's most famous feature, the glass floor and lookout level, allows visitors to stand more than 1,100 feet above the ground and look straight down through the panels of specially reinforced glass. These panels, only 6.4 centimeters or 2.5 inches thick, can support the weight of 14 hippos. That's an example of how engineering can merge functionality with some thrills. But beyond tourism, the original purpose of the tower is vital. It continues to house hundreds of antennas for radio, television, and mobile communications, transmitting across the greater Toronto area and beyond. The design does allow for future upgrades in equipment, which keeps it technologically relevant decades after its construction. At night, though, the CN Tower becomes a luminous vertical beacon, illuminated by programmable LEDs that dance across the surface. And from the streets below, it seems weightless, like a thread of light that stretches skywards. Yet beneath the smooth exterior is one of the most advanced and resilient systems ever created. It stands, quite literally, as one of the most stable and awe-inspiring structures ever to defy gravity. Number 2. The Millau Viaduct, France. Stretching gracefully across the Tarn River Valley in southern France, the Millau Viaduct is one of the most extraordinary bridges ever built. A structure so high and delicate it seems to float. Completed in 2004, it's one of the tallest bridges in the world and one of the most elegant expressions of engineering. It was designed by British architect Sir Norman Foster and French structural engineer Michel Verlago. This represents the perfect marriage of architecture and structural efficiency. The bridge carries the A75 motorway across a deep valley near the town of Millau, which connects two plateaus separated by one of France's most scenic landscapes. The challenge was to build a bridge that could span 2.4 kilometers or 1.5 miles across the gorge and rise to a height of 343 meters or 1,100 feet at its tallest point. That's way taller than the Eiffel Tower, without disrupting the valley's natural beauty. The construction process was as remarkable as the design. Rather than building the deck in sections from below, a process that would have been dangerous and time-consuming, the engineers assembled the deck on both sides of the valley and then gradually slid it into place using hydraulic jacks. This method required precise synchronization between multiple teams and real-time monitoring of alignment to within millimeters. The tallest pier, P2, measures about 245 meters or 804 feet from the base to the summit, making it the highest bridge pier ever constructed, until that one in China is probably going to take it over. The steel deck, weighing over 36,000 tons, was fabricated in segments and launched from both ends to meet perfectly above the river. But despite its immense height and slender proportions, it's exceptionally strong and stable. It can withstand winds of up to 130 miles an hour and expand or contract several centimeters depending on temperature. Norman Foster described it as a dialogue between nature and technology, designed to complement the land rather than dominate it. Well, seen from below, the slender piers disappear into the mist while the deck seems to glide effortlessly across the valley. Since its opening, it's been praised worldwide as one of the greatest engineering accomplishments in the modern era. It did win the 2006 International Association for Bridge and Structural Engineering Award, and it's become a major tourist attraction in its own right. It's not only one of the highest bridges ever built, it's one of the most graceful. Every component, from its tapering piers to its whisper-thin deck, was designed to be in balance. And in doing so, it achieves what great architecture always strives for: harmony between strength and weightlessness. It is a monument to the mastery of gravity. Number 1. The Lotte World Tower in Seoul, South Korea. Standing 555 meters, or 1,819 feet above Seoul, the Lotte World Tower is not only one of the tallest buildings on Earth, it's also one of the most technologically advanced. Completed in 2017 after 13 years of design and construction, the tower does redefine what a super-tall skyscraper can be. The tapering profile appears to stretch impossibly into the sky, while an intricate system of structural supports, tuned dampers, and composite materials allows it to withstand the immense forces of gravity and wind. Designed by Kohn Pedersen Fox Associates, this tower reflects South Korea's blend of innovation and tradition. The shape is inspired by traditional Korean ceramics and brushwork, its slender curved form rising from the Han River basin with an elegance that conceals its strength. The building has 123 floors above ground and 6 below, housing offices, luxury residences, retail space, even a 7-star hotel, and an observation deck that offers amazing views of Seoul. To ensure stability at this extraordinary height, engineers from Leslie E. Robertson Associates, they're renowned for their work on the original World Trade Center, developed one of the world's most sophisticated damping systems. At the very top of the tower sits a 1,000-ton tuned mass damper, a huge counterweight that moves in opposition to the building's sway. When high wind or earthquakes cause the tower to oscillate, the damper shifts slightly to absorb the energy and keeping the motion to a level that's imperceptible to the occupants. The tower rests on a foundation raft that's nearly 4 meters or 13 feet thick, supported by 172 reinforced concrete piles drilled more than 148 feet into the bedrock. The outer facade features double curved glass curtain wall composed of 17,000 individually fabricated glass panels. Each piece was designed to resist strong pressure differentials and provide thermal insulation. Despite weighing over 20,000 tons, the facade maintains a seamless, fluid appearance, which reinforces the illusion that the tower is lighter than air. The uppermost section of the tower contains Seoul Sky, the world's highest glass-floored observation deck, located at 478 meters or 1,560 feet. From here, you can look out directly downward through laminated safety glass suspended nearly half a kilometer above the ground. It's an amazing experience that physically conveys the building's mastery over gravity. At night, the tower transforms into a beacon. LED lights that ripple across its facade create dynamic displays that can be seen across the city. The lighting system, which was integrated into the tower's structure, adjusts to the wind speeds and temperature, which subtly shift in intensity to conserve energy. The tower doesn't simply rise above Seoul, it redefined the skyline, appearing almost weightless despite its scale, and every element from the aerodynamic taper to the hidden structural skeleton was engineered to manage forces that would destroy lesser buildings. In an era where height alone no longer defines greatness, the Lotte World Tower achieves something rarer: balance. It combines technology, art, and durability into a single vertical form that defies gravity with both strength and grace. It's a modern pinnacle of engineering that literally and symbolically elevates the city beneath it.